Hello everyone, welcome to my channel. In our thermodynamics series, now we will discuss a new topic, heat and work. Heat is basically the another form of mode of transfer of energy. Let us consider one example. When we place a cup of tea, you will observe after some time the tea present inside the cup becomes cold. What will happen? Basically, the heat from the hot tea present in the cup will be transferred from hotter body to colder body. Surrounding is cool and the tea is hot. And the heat is transferred from the cup of tea to the surroundings, means hot body to cold body. So heat is the another mode of transfer. So next it is donated by Q. Now in our last video I have already explained that if we consider this as a system, if we give heat to the system, means heat is absorbed by the system, then it is always positive. And if the heat is given out by the system, heat is released by the system, then it is always negative. And the SI unit for heat is joule. These are some simple points which we have to remember about the heat. Now next come to work. Work is basically what? Force multiplied displacement. Now what is displacement? Let us consider one example. Here is a one man. What will he want to do? He want to push this box and place it here. What will happen? He will apply a force on this box. Then what will happen? Initially the box is present at this position. It will shift to this place. Then it will displace from here to here. So this will be the displacement. Means when we apply force on an object, that object gets displaced and the work done is known as force multiplied displacement. So work done is basically equals to force multiplied displacement. This is generally a mechanical work. In thermodynamics, we will basically deal with pressure, volume, work done, like work of expansion or work of compression. This is basically deals with gases. Now we will derive an expression for work done, pressure, volume work, or work of expansion or compression. Let's begin. Now for pressure volume work, what we have to do? We have to consider a gas. Here is the gas present in this cylinder. These are gas molecules. Consider a gas enclosed in a cylinder. There is a gas inside the cylinder fitted with a frictionless piston. Fitted with a frictionless piston. This is basically piston. Suppose the area of cross section. The area of this cylinder is a square centimeter. And the pressure on the piston means the pressure applied on the piston externally, that is equals to P. These all are the terms you have to know. Next is the distance through which the gas expands. As the gas expands, because the pressure applied by the gas molecules is more than the external pressure, so that's why gas expands. There are two situations. Consider an example. There are two situations. Here, if the inside pressure is more than outside, then gas will expand. But in case of reverse, in reverse case, what will happen? If the external pressure is more and internal pressure is less, then it will compress. So here we are dealing with the expansion case. What will happen? The external pressure is less than the internal pressure. So the molecules will get expand. After expansion, the displacement occur, that is represented by dl. Now we know that pressure is equals to, we already know pressure is equals to force upon area. Now from this expression, what will be the force? We can rewrite it as force is equals to pressure multiplied area. Now we already know that Work, what is work? Work done is equals to force multiplied displacement. Now is there any force value? Yeah, this is the force. We can put this value, this force, into this equation. What will happen? Pressure multiply area multiply dl. Now you can tell me, this is area, this is length. What is the volume? Basically volume is length multiply length multiply length. Length multiply length is area. When we multiply area with length, what do we get? Volume. So we can write it as W is equals to P. These together can be written as dV. So this will be the expression of work done. Further it will be solved. As there is a small increase in volume, this displacement is very small. dl means small change. When we write it as dl, d means there is a small change. You can see two variables. If we write delta L, this means large change, and when we write dl, then it is called small change. Here the change is very small. If displacement is small, then there is a small increase in volume. If the increase in volume is very small, then the small amount of work done is given by this. This equation can be written as this. Delta W means small work done, P dV. Now gas expands from initial volume V1 to V2, then the total work done is given by. When we want to find total work done from the small amount of work done, we have to integrate it. Now this case will consider as a work of expansion, and it occurs irreversibly. Irreversible. When it is irreversible, then pressure remains constant. So we can write it as W is equals to P will be outside the integration, V1, V2, dV. We are writing P outside the integration. The reason being constant is not integrated. Constant term को अपन integrate नहीं करते. Now we will integrate this dV with respect to volume. Now what will happen? We can put these values on integrating. What will become? V2 minus V1. This is the change. Final minus initial. This is the final minus initial, means change in volume. We can write it as W is equals to P delta V. So this is the work done. Work of expansion. Now understand this thing. Work of expansion means work is done by these gas molecules to expand. When work is done by the system, then it is always negative. So this is the general expression. It is considered both for compression and expansion. How it is considered for both? You just have to remember this expression. W is equals to minus P delta V. Here P, you can write it as P is external pressure. Means this P is the external pressure. So this is the final expression for work done. Now see how this is applicable to both compression as well as expansion. See, for expansion, volume will increase, final volume will increase, means V2 is greater than, this is for expansion. For expansion, what will happen? Final volume will be more than initial. If we put this volume is more than this, your value delta V will be positive or negative. If V2 is more, then it will become positive. If delta V is positive, here is negative, overall expression will be negative. So this is work of expansion. Now we consider work of compression. Similarly, consider the work of compression. In case of compression, what will happen? In case of compression, this volume will decrease and it will nearly like this. Volume will decrease, means final volume is less than initial volume. So V2 should be less than V1. If V1 is greater, now if we put this in this expression, W is equals to minus P external V2 minus V1. This is final volume, this is initial volume. If initial volume is more, then this delta V is negative. This negative, overall W is positive. So work of compression is positive. This is the pressure volume work. Now this work done is in irreversible case. Now we will discuss work done for reversible process. Now we will discuss the work done in case of isothermal reversible process. First, isothermal. Isothermal means temperature remains constant. This is the work done we already know. Here this is a small amount of work done. This P is the external pressure and this dV is the small volume change. So we can also write it as dW is equals to minus PdV. This will be your first equation. After this we know that ideal gas equation PV is equals to nRT. Understand? Now from here we can find out the value of P. This is your second equation. Using this second equation, first, now what will be your expression become? dW is equals to minus, instead of P you will write nRT over V dV. Now this is your equation number 3. We want to find out the total work done. This is the small amount of work done. In the last derivation, what we did to find the total work done? Integration. Now integrate. Integrate it. What will happen? Integration of dW is equals to minus integration of V initial to V final. V2 लिखते हैं. This is nRT dV over V. Now, in the last derivation, I said that pressure is constant. So we write that pressure outside the integration sign. So here in this case, these three things are constant. So we can write it as dW, integration of dW is W, which is equals to minus nRT. Now inside of integration, V1, V2, dV divided by V. Now we have to integrate dV by d. This means you have to integrate 1 by V. What will be the integration of 1 by V? Means 1 by x. You can write it as log x. So here you can write as log V. So integration of this is W is equals to minus nRT log V. Here is mod. On the mod you have to write these two values. After this, W is equals to minus nRT log V2 minus V1. W is equals to minus nRT. You have also learned this concept in mathematics that when any two log terms are in subtraction, then we can write it as log V2 divided by V1. When there is a minus sign, you can write it in divide form. This is the final expression for work done. Now this is the natural log. If we want to remove this natural log, we have to multiply this term with 2.303. What will become? W is equals to minus 2.303 nRT log V2 over V1. You can also write it as V final divided by V initial. When here is a negative sign, this is always work of expansion. This is always work of expansion. Now for work of compression, what is the expression? Plus 2.303 nRT log V final over V initial. This is work of compression. This is the work done in terms of volume. Now we can also find this work expression in terms of pressure. Initial terms, P initial, V initial equals to nRT. P final, V final is equals to nRT. If in both the equations right side is same, then we can equate the left sides. So P initial, V initial equals to P final, V final. Then we can also write it as V final. Take this V initial this side. V initial, P initial, then P final will come here. P final. Now understand from here. V final divided by V initial will be equal to P initial upon P final. Using 7 in equation number 6. What will be your expression? Minus 2.303 nRT log P initial over P final. You can write it as P1 over P2. It's your choice. This is the another expression for work done in terms of pressure. That's all about heat and work concept. If you feel any doubt, you can ask in the comments. Thank you and have a nice day.